subscribe and press this bell icon to never miss another lecture video. Welcome to GATE ESE lecture. We are in lecture number 35 of signal system, and this is your discrete time system. And here we are going to discuss about the classification of discrete time system. It's exactly as that of continuous time system. All the principles, all the logic, all the properties, all the definitions will be same, but only difference will be there. It's the kind of signals that we are going to do, the kind of signals that we are going to associated with, or the kind of systems that we are going to associated with, that will be in the discrete time domain and nothing else. वहाँ पे बस x of t हो रहा था, यहाँ पे x of n होगा. Okay, वहाँ पे आप h, you're applying x of t and you're getting y of t as your response to this excitation. Here, instead of writing that, you're going to write x of n and you're getting response at y of n. So only difference will be there through the examples. Baki, the property will be the same. Now there is two very important kind of systems get added, that is finite impulse response and infinite impulse response system, and recursive and non-recursive systems. This is the two very important and extra classification that is get included, that's get included in discrete time system classification. Other than this, other people are same, like stable, unstable, causal, non-causal, linear, non-linear, time variant, time invariant, static and dynamic system. Now without wasting a time, let's get started with static and dynamic. Before getting to that, we have discussed about the main response of discrete time system in during the introduction to discrete time system wale video lecture mein. But now let me tell you about the equation, that is a constant coefficient difference equation, which governing the input and output of an LTI discrete time system for n equal to 1. If I told you this system will only like this equation is only going to be like valid if your n, which is the order of your system, it has to be less than equals to m. I told you this thing, right? Now for n equals to 1, the standard equation that you will get, the discrete time system, which you will get, the equation that you will get for n equals to 1, that will be nothing but your first order system, because through n you are defining the order of the system, and for n equals to 2 you will be defining the second order system. Okay, now for n equals to 1, what will be the equation? The equation will be y of n equals to minus a1 y of n minus 1 plus b naught x of n plus b1 x of n minus 1. For n equals to 2, similarly, as it is starting from minus a1, so it will be starting from minus a2 y of n minus 2. Similarly, तुम बोलो सर माइनस a1 y of n minus 1 आ जाएगा, फिर हाँ, फिर प्लस बी नॉट से स्टार्ट हो जाएगा x of n का, हाँ, देन इट विल एक्सटेंड टू b1 and b2 सर, हाँ, so here will be x of n minus 1, absolutely correct, x of n minus 1 and x of n minus 2 sir. Clear? So these are the two equations that you need to remember. Assessment reason के लिए बहुत important है for GATE and engineering service exams. Now let's start with the static and dynamic system, and as we know, I told you, remember, I'm not going to show it to you. I told you that static system means संन्यास होता है जो, गौतम बुद्ध है जो, वो है static system. Like it only depends on carpe diem. Remember the carpe diem, to only seize the day. Dead Poet Society, I told you, na, static system is only depending on the present input, the present instant time. He always lives in present instant of time. So the output of a static system is only dependent on the present time input samples. Now this is a new word that we add here, because static discrete time system, I can say static discrete time system, dynamic discrete time system. Now if any system that is not depending on present instant of time, present time input samples, that will be nothing but your dynamic system. As simple as that. Now as it is only depending on carpe diem case, that is your present time, that is memoryless, and it does have memory. Now let's solve a couple of examples. Here you can see here your output. This is the response of the discrete time system for input xn. If you're applying x of n, this examples means if you're applying x of n to a system, our system output is given as a into x of n. That means the system is producing a multiplying factor, that is a. Clear? You need to understand this in this way. I think I have discussed with you this concept in continuous time domain. Okay, now here you can clearly see the output is completely depending on the present instant of time time ka input ke upar. Okay, here you can see clearly y of n is completely depending on the present instant of time. Both the cases. अगर ये x q ना हो कि यहाँ पे q होता तो ये हो जाएगा फ्यूचर इनपुट के ऊपर डिपेंड करता. Clear? But here it is present input के ऊपर डिपेंड कर रहा है. So all of them are static discrete time systems. That is, it is depending on the present as well as past input. So ये dynamic हो गया. It is depending on the lot of past inputs. It depends on lot of past inputs and future inputs. So these three of them are a dynamic system, discrete time system, but two of them does have a finite, listen to this, finite memory. Listen to this. And it is a dynamic system which is having infinite memory. Clear? These two are a dynamic system with having finite memory, and this is having a discrete time system which is having infinite memory. Now moving on to the time variant and time invariant case, it is the same principle that we have discussed in our continuous time domain, that is